In today's video lesson, we're going to go ahead and do applications of functions. Function notation is just another way to write an ordered pair. So if I give you the ordered pair of -6, 1, I would write it in function notation by going ahead and placing the -6 into the parentheses of f here. That's my x value. And then go ahead and have f of -6 equal the y value of my point, which will go ahead and be 1 for this problem here. Same thing for the next problem. When I'm given the point 5, -8, I go ahead and place the 5 into the parentheses x position of my f of x. This time it's f of 5 here. And then it will equal my y value, which for this point is -8 here. So it reads f of 5 equals -8. Now I can go backwards when I have function notation, reading f of -9 equals 2. I can go ahead and take what's in parentheses as the x value of my point, and I'll take what the f of -9 is equal to, which is 2 in this case, as the y value of my point. We go ahead and talk about one more example. We want to write f of 3 equals -4 as an ordered pair. I take what's in the parentheses, that's my input x value. That's going to go in the x value of my point. And the output y value is going to be the y value when I write it as a point. This is going to help us understand the steps to find function notation when we're given a graph, especially when we're looking at the x value being given. So the first step is we're going to look for the number in the parentheses on the x-axis. So let's start with number 1 here. I see g of 4. So again, I find that on my x-axis right here. That's where 4 is. I then, step number 2, draw a nice vertical line straight up and down the entirety of my graph with a nice highlighter there. I then want to go ahead and circle the point where the vertical line I just drew hits the printed graph I was given. With that point, I answer with the y value. Well, I just circled 4, -1. So that means my answer is -1, since that's the y value of that point I just circled. Let's try the next one. Same steps. We go ahead and start with finding 2. That's in the parentheses. That's my x-axis value. And I draw a nice vertical straight line up and down my whole graph. I circle where it meets the printed graph, which is this very top point. I'll name that point 2, 5. And I answer with the y value output of that point. Next input x value I have is g of 0. So that's going to go ahead and be the x value I'm looking for on the x-axis. That highlights this y-axis here. And I circle where that point meets my highlighting and printed graph. Going to name that point 0, 3. And I answer with the output y value of that point, which is 3. Last one, we go ahead and find -3 on our x-axis, and I draw a nice vertical line, circling where that vertical highlighted line meets my print in my graph. That is at -3, -2. Answering with the y value, -2 for my answer there. In the next steps, we want to find function notation on a graph given the y value. So I'm going to work backwards now. Here's how it works. For my first example, I have f of x equals 3. So I go ahead and start by finding that on the y-axis this time. And I'm going to draw a horizontal line now because I'm working backwards. I still circle where that horizontal line meets my printed graph, naming the point that's at 1, 3. But this time, because we're working backwards, we give the x value of that point. X equals 1 is my answer for f of x equaling 3 on my graph. F of x equaling 1, let's take a look at this one. Find 1 on your y-axis and draw a horizontal line. Circling it where it meets my graph is right here at this point, 0, 1. And I answer with the x value, so that's x equals 0. Finding the next value, f of x equals negative 1, that's going to go ahead and be on the y-axis, highlighting straight across a horizontal line at negative 1. Circling where that meets my printed graph, that point is negative 1, negative 1. And I answer with the x value of that point, x equals negative 1. Last one is an f of x equaling negative 5. So that's my y value output being negative 5. Highlighting that horizontal line and circling where it meets my graph. Be careful because it meets just before that arrow and it's never going to meet on an arrow. So that's going to be negative 3, negative 5, that point I just circled. Answer with the x value, x equals negative 3 on my graph for f of x equaling negative 5. We've done domain and range before, and now we're doing it in context. The graph of d of t represents Gulliver's distance from home after t hours. So looking at the label on my x-axis, it says time in hours here. So that's going to be talking about my x, or in this case, they use the letter t for that. Then we look at the usual y-axis and we see it's labeled with distance in miles. So that's going to go ahead and be our y, or in this case, d for distance. So I'm using different letters, but applying it for the same idea. For the domain of my graph, I look all the way left and I see my graph starts at the point of 0. I do include that point that is part of my graph, so I put an equal sign under my less than sign. And this time, instead of x, I'll put t, since we're talking about time for domain. Then I'll have it less than or equal to the point on the all the way right side of my graph, 12. So my domain of the graph is 0 less than or equal to t, which is less than or equal to 12. For the range here, I'm looking at the y values down, or the y-axis, our d-axis in this case. So we go ahead and look at the lowest point I have. Well, these are my lowest points. Both are at the y value of 0. Include that point. It is a filled point. This time I'll use d for distance, since that's what our range is this time, and that's how the axis is labeled. And I go to the highest points. These are my two highest points. Luckily, they have the same y value of 12. So for our range, it is 0 less than or equal to d, which is less than or equal to 12. Now, because we're talking about context, we want to think what domain values never make sense for this situation. Well, my domain values are going to be representing time. When we talk about time, especially in the time traveled away from your home, it's going to never include negative numbers. So what domain values never make sense for the situation, and that will be negatives here. What range values never make sense for this situation? Taking a look at the range y-axis again is going to go ahead and be our distance here. And distance traveled from home. We're going to go ahead and have the same situation where we can never have negative distance traveled. When you're traveling to school, even if you go a roundabout way to go stop somewhere, you're still gaining distance here. You're never going to go negative distance. In the next example, we're representing the cost for admission to Hershey Park as $60 per person. The cost of admission, C in dollars, is a function of the number of people, X. So we want to find X in this given situation. And remember, X is our input value, also known as our independent value. And that's going to go ahead in this case being the number of people here. Specifically going to Hershey Park. We're going to talk about what makes sense for that domain since it is number of people. Well, I'm going to say what makes sense is whole numbers. We don't want half a person, and it has to be greater than or equal to 0 for that whole number because I don't want negative people as well. So I'm going to write the reasoning that there's going to be no negatives or half a person. So no negative people or no half a person. That's why I'm sticking to greater than or equal to 0 for whole numbers. Now that I have that independent restriction, I want to go ahead and circle all possible range values, which is dependent on that independent variable, for the function defined by c of x equaling 60x. Well, right away, I know I'm going to be plugging into this function numbers that are greater than or equal to 0. So I can cross off the first one option of negative 60 right away. And that's going to be because there are no negative people. We can't have a negative person. 60, I'm going to go ahead and circle because guess what? The price of one person is $60. So that is a fair range you can pay here. Well, let's think about it this way. What if I had two people? Well, 2 times 60 would be 120 here. So that's why I'm circling this because that's counting for 2 people's admission. When I do 60 times 3, that comes out to be 180. So that's going to be 3 people's admission. So all of those are possible values here. We're going to go ahead and look at 90. And I'm thinking that that is what 60x is equaling to. When I have that statement and I divide each side by 60, that comes out to a decimal here, or a fraction. And we can't have decimal or fraction people. So no decimal for people. We need a whole person. That's also going to be the case when I set up 160 equals 60x. When I divide each side by 60, do that in the calculator, you do get a decimal. And we cannot have decimal for people there. So that's going to apply to both of these. Take a look at the 120 and the 180 we circled. I can set those up the same way I just did the 90 equals 60x and the 160 equals 60x. But when I set up 120 equals 60x and divide each side by 60, I get 2. Because it's a whole number greater than 0, that's a possibility for my range. And when I do the same with the 180 I circled, that again gets divided by 60 on each side, just like I did the others. But this time it's a whole number of 3. We're going to do the first function word problem where we're given an equation and have to use it. A baseball team offers a promotion. Normally it's $12 for bleacher seats, but every specially marked soda can take 50 cents off of the price. The function can be represented as f of x equals 12 minus 0.50x. So we're going to go ahead and define our variables first. So I'm going to think about what can change in this problem. Right away, I know I can change the number of specially marked soda cans I have. So that's going to go in for my x because I could have 1, I could have 2, I could have none, and I could have 100. What's going to change based off how many soda cans I have is the cost of our bleacher seat. Now we're going to go ahead and find the value of f of 2 here. So remember, I'm going to go ahead and copy down my f of x function from above that they gave me. F of x equals 12 minus 0.50x. And everywhere I have an x, I'm going to replace it with the number 2 here. And remember, X is going to be my specially marked soda cans. So I'll highlight that in blue to help me remember, especially for the next problem. Whenever we're at an X, I replace it with 2. Remember, the left side's just a notation, so we're going to copy that down and ignore it. But we need to do PEMDAS and GEMDAS on the right side. Multiplication comes first, so I'll keep the 12, but I'll multiply negative 0.50 times 2, which will get me a negative 1. And then I'll go ahead and subtract 12 by 1 to get 11. Bring that function notation down to have the final answer in function notation 4. Don't forget, we can always do it in the Desmos calculator. Here's how. In Desmos, you type in the given equation, f of x equals 12 minus 0.50x. And then underneath, you put in what you're trying to solve. We're trying to find f of 2, type it in, and it gives me the answer of 11 right there, which checks our math for what we just did by hand. Now we're going to talk about what this means in context, because that's going to be the answer to B. In the question we just solved, what it meant in context was that if you have 2 specially marked soda cans, then the price for that bleacher seed is going to be $11. For example C, we have how many specially marked soda cans. So I'll go ahead and highlight that on our blue because that's going to be our X value we're looking for. We're not given it, we're wondering how many. Do you need to only pay $10, so that's our number we're given, for bleacher seeds? Well, that bleacher seed again was going to be my Y value. So here's the thing. I am given my Y or f of x value, but I'm not given my x. So how I'm going to set this one up is f of x equaling 12 minus 0.50x. That's just copying down the original function. But I have to keep x because I have to solve for it. But what I do know is my f of x or my y equals 10. So this is how I set up my equation. Solving it by hand, we go ahead and subtract 12 from each side, getting my x by itself closer to the goal. But now what I do here is I have a negative 0.50 multiplied to x, so I have to do the opposite, which is division. What I do to one side, I do to the other, and it cancels out here on the right, and I actually do that in a calculator on the left to get 4. Now that is going to be my answer, but let's put a unit on it to answer the question. How many specially marked soda cans? The answer is going to be 4 specially marked soda cans. Okay, let's do it in Desmos because again, you'll have Desmos the whole time with this. I just like to show you by hand first. This time we're going to go ahead and type in the equation that we replaced the f of x with. So that would be 10 equals 12 minus 0.50x. And we don't get our answer over here on the left column, but we get it visually on the graph. You'll see I have that point that the purple line goes through 4, 0. The answer is the x value because that's what we were looking for, the specially marked soda cans, which were x. And the answer was indeed 4. We're going to go ahead and continue our function word problem notes with an equation example. A pizza place sells 12-inch plain cheese pizzas for $15.50. Each topping is an additional $1.85 added to the total cost. This scenario is represented by the following function, f of x equals 15.50 plus 1.85x. First, we want to define your variables, then answer the questions that follow. So for x here, we want to talk about what's going to be changing or added each time. Well, that's going to be specifically here, each individual topping. So each topping is an additional amount. Then we're going to go ahead and look at our f of x or y, which is specifically what's going to be changing because of each toppings being added, because of that x value specifically. Well, that's going to be the total cost of our pizza. In part A of this problem, we want to go ahead and find the value of f of 3. So when I find the value of f of 3, I'm going to write down the initial function equation I'm given in the problem here. And in place of x, every single time I have it in the function and in the problem, I'm going to go ahead and replace it with a 3. Remember what happens is we have f of 3 now on the left side staying as a notation, but on the right side I have 15.5 plus 1.85 multiplied to the now 3 in its place of x. Again, left side's just notation and we solve the right side by doing the order of operations. 15.50 stays as is, but I do the multiplication of 1.85 times 3 to get my answer of 5.55. From here now we do our last order of operation of addition, which comes to give me a 21.05 as a final answer. Before we talk about what that means in the context of the problem, we're going to go to Desmos. In Desmos, I type in the original function given in the problem, f of x equals 15.50 plus 1.85x. And then underneath, I put in what I'm trying to find. I was trying to find the value of f of 3, and that gives me my answer in the gray box of 21.05. In part C of this problem, we want to find out how many toppings. I'm going to go ahead and highlight that in blue because that's our x value here. Can you get if you only have $24.75 in your wallet? So we want to think about where we plug in that 24.75. Well, I'll go ahead and write the original function given in the problem, f of x equals 15.50 plus 1.85x. From here, like I said, I want to solve for x, so I'm going to keep that x. But what I'm going to replace is the y, which is my total cost of the pizza I can have, being $24.75. So I'm going to highlight that $24.75 in pink and also write it in pink because that's representing the total cost of the pizza being known. My f of x and my y is known, but my x is not, so that's what I solve for. We go ahead and draw our line here. First step tells me to get x by itself by subtracting 15.50 on both sides of my problem. Cancels out on the right side, leaving just 1.85x. And on the left side, when I do the subtraction, I get 9.25. We do our next step of dividing 1.85 on each side. What happens on the right is it cancels out to leave just x. And then on the left, when we do that, 9.25 divided by 1.85 in the calculator, we get 5. We're going to label this 5 being the toppings here because that answers our question of how many toppings we can get when we only have $24.75 in our wallet. We go ahead and use Desmos to get this answer as well. So remember, I'm doing it by hand just to show you, but you're going to have access to Desmos, so might as well use it. In Desmos, again, I'm going to have the original function typed in that was given to me in the problem. But now I go ahead and delete the f of x and replace it with what I was given to have f of x or y equal to a 24.75. That also is seen right here on our first line of our problem, what we did for this step here. That way I let Desmos do all the work to solve it down to an x value of 5 representing the amount of toppings.